Yeah, hi, my name is Matt Stack. Hello, is that good? Yeah. My name is Matt Stack with NVIDIA. I'm going to pick up where we left off yesterday and talking about our Nsight tools, our profilers. So we have 3 profilers. 2 we're going to cover, Nsight Systems and Nsight Compute, and then 1 is called Nsight Graphics, which is more for like DirectX 12 and ray tracing and real-time graphics. We won't cover that. So Nsight Systems is like our system-wide profiler, so you can see the interconnections between the different processes, like your GPUs, your CPUs, your different APIs, your MPI, stuff like that. And you use that typically to identify your hotspots or just some obvious memory transfers that need work or some random synchronization. And then you will use your newfound knowledge of like what are the hotspot kernels, and then you dive into Nsight Compute, which is a deep dive zoom in on like one specific kernel, and you can see how that your algorithm is performing relative to the maximum throughput of whatever device you're running on. And then we like to think about it as like a cyclic graph. So after you do that, you take it back to Nsight Systems and you see if your performance was better or worse, or it might have shifted, like you might have some more memory transfers now. So we like to think about it in kind of like, you don't do Nsight Systems once and then finish on Nsight Compute. You typically want to go back until you have some performance that you're happy with. We also have a 4th one we'll talk about, which is if you're familiar with the CUDA mem check. That was technically deprecated, and there's a drop-in replacement called Compute Sanitizer. I'll just briefly cover. And all 3 of these, or at least Nsight Systems and Nsight Compute, are available in the NVHPC in CUDA toolkits, and you can just download them standalone. So Nsight Systems is our first step. I mentor a lot of hackathons, and this is pretty much every team, every mentor does Nsight Systems first thing. It's our system-wide view of the application. So you can see a single timeline for your GPU, your CPU, MPI, memory patterns. You can have multiple GPUs, multi-ranks. And like I mentioned before, it's for identifying hotspots for performance tuning. You want to look for places where the GPU is idle, so like bare spot in the profile, excessive synchronization, suboptimal memory traffic, or if you see like big memory traffic, like a copy to host, a big kernel, and then a big mem copy back to the host, you might be able to see that and think, oh, maybe I could actually like use overlapped compute and memory transfers and break it up and essentially hide the memory transfer. And then I included 2 docs, a great one that is hosted at ALCF, and then just the Nsight Systems user guide from NVIDIA. And then these are available on Linux, so x86, Power 9, ARM, Windows, and then on Mac is the host only. It's similar to what was shown with Tau. You can copy back your profile to your local and then view it in our GUI. So if you haven't seen an Nsight Systems profile before, it kind of moves like linear, like times on the x-axis, and then you'll see like little blips, almost like a seismograph of like GPU activity. If you haven't seen it before, it can be a little bit of some mush, but I always ground myself with the device row on the top left. You'll see CUDA hardware, and it'll say Tesla V100. This was profiled on the V100, and then it all moves via the x-axis, and you can see that this had some GPU activity. It uses unified memory. I'm just kind of going down. There's a cool flag you can add that shows your page faults. So if you're familiar with CUDA unified memory, the way the operating system transfers the memory back and forth, as you call it, is through page faulting. So you can see it on a timeline. And then if you have MPI or multiple devices, you'll see them there on that row. And like I mentioned, like if you see any like bare spots or anything like that, or if you see like a especially large kernel, that's kind of where you want to focus. I do a lot of hackathons, and there's usually always like at least one like aha moment where you think you know something, but just seeing your code on a timeline for the first time yeah, is extremely helpful. And then the third little bullet point is that there's a special user tag called MVTX ranges. And those are little host plugins where you just push it onto the stack and then pop it off. So you can just see like what's happening in your own words rather than just a bunch of CUDA mem copies, kernel launches, etc. You can like put your science and your algorithm into it. So it's helpful for other people. You can also get a little bit more detailed view. If you right click on any of the rows, you can scroll down to show an events view, and that's the, will pop up here with the rows. And I did that for the GPU page faults, and you can see all of them. It just gives you a little bit more information, like there was a unified memory page fault that was a read of size 224 pages at this time, this duration, blah, blah, blah. And you can see like a very thin vertical line on the timeline, and that's where it was. So trial and error, if it's your first time, your first profile might look like this. Something probably went wrong. There's no GPU row if you expect it to be running with CUDA. On the top right, it says there was 1 error and 58 warnings, which is never good. So it's okay if this is your first profile. You probably just missed a flag or something. This is very common. And then this is a slide you can refer to later on how to run Nsight systems on Polaris. There's a great beginner's guide, and we'll be going through that in the hands-on or any questions you want to ask. Generally, it's just Nsight profile. You give it a output file, and that's the thing that you're going to copy back to your local and then view in the GUI. --stats true just gives you a little bit of information on the command line just before you copy it over, and then your app executable. And then 2 additional flags that I always find helpful. If you're using OpenMP or OpenACC, you can consider adding --trace OpenACC or OpenMP. By default, Nsight Systems traces API calls from CUDA, NVTX, OpenGL, and the operating system runtime. OpenACC and OpenMP, if they run on the GPU, are just boiled down to CUDA anyway, so you will see it in the CUDA API, but if you want an extra row, we can see your OpenACC or your OpenMP just for verbosity or whatever. You can add those there. And then the flag I mentioned before, if you're using CUDA unified memory, you can add page faults from the GPU and from the CPU. This will add a little bit more time to your profile, but is likely worth it. And if you find that your Nsight Systems profile is taking a really long time, there are a few tricks, like you can tell it to stop after 30 seconds or stuff like that. And then, yeah, those 2 screenshots are just, you load NVHPC on Polaris and do which Nsight Systems, you'll get Nsight Systems, and then same for the standalone CUDA toolkit. Oh, I should mention that Nsight Systems is technically a CPU profiler. It has a little stack trace, but it's like not too great. Unofficially, definitely recommend like ARM Forge. But it is a very active improvement area for Nsight Systems just because we have our own CPU coming out. So we want it to be kind of like a one-stop shop. And then, so once you identify your hotspot, like a kernel that you know is just your main compute loop or something that is taking longer amount of time than you anticipated, you can profile it in Nsight Compute, which is our kernel profiling tool. It's a zoomed in profile on a CUDA kernel, typically performed after Nsight Systems. One of the cool things you can do is you can compare multiple kernels, and it will show you like the delta performance difference. And that's just a really quick way to say, like, to see if did my code optimizations make a change in the right direction or not. There's also opt-in source code profiling, so you can, with 2 flags, you can tell Nsight Compute to take a copy of your source code, and then in a few slides we can see like it will tell you like which specific line has what stall and how many executions. And a newer feature is like you can see register dependencies. So if you have a stall on one line, you can kind of trace back the register dependencies up and see where the bottleneck is. Similarly available on Linux, x86 Power, ARM, Windows, and Mac host only, and then also included some documentation. So this is typically, if you open up Nsight Compute, what you'll see. The first place to look is the speed of light section, or the GPU throughput. So you'll have compute and memory, and this is relative to the maximum throughput possible on your specific GPU. So this has the possibility to change if you go from like a V100 to an A100 or an H100. It might wobble a little bit just because your algorithm might not perform the same on faster memory, faster compute, but it shouldn't 180. If I didn't take a screenshot of this, but if you scroll down, there's also a roofline analysis, if you're familiar with that. That it has the performance on the y-axis and then arithmetic intensity on the x-axis, and it's kind of very similar to this GPU throughput, but you can just see it in 2D. This also shows that this report contains source files, which I think we'll talk about. Yeah, we'll talk about next. And I'll show you how to include those if you haven't done that before. So this is the source view. You would get here by clicking on page. This shows details. And then you will go to page source. And then your view will be source and SAS. And then on the left, you'll see like your user code and some hotspots. There's a number of these if you scroll. So like stall reasons, instructions, executed hotspots, stuff like that. And then this little line, you'll see a heat map of where the most values will be. And then on the right, you'll see the assembly, and then you'll also see the register dependencies that you can map back and forth. You'll also be able to see like if you're using fused multiply and add, which is great on NVIDIA GPUs, you'll be able to see that on the view on the right. One thing I'd like to note for Nsight Compute is don't ignore these little expert analysis messages. They're a little triangle, little yellow triangle. They are triggered if certain conditions are met. So Nsight Compute obviously doesn't know your algorithm or what science you're doing, but these expert analysis are actually very useful. So you can see one says like occupancy limiter or stall reasons. It just takes a second to read them, and they're usually pretty helpful. How to run Nsight Compute on Polaris. Same beginner's guide, which is great. A typical Nsight Compute command would be like enku your profile. It's a little bit harder than Nsight Systems because you just tell Nsight Systems to profile your whole thing because it's a system-wide view. Nsight Compute, you want to profile a specific kernel or maybe like a handful. So you want to give it -k and then regular expression, the kernel name. And if you're interested, there's actually a way in Nsight Systems where you can right-click on a kernel and then scroll down, and it will say like, oh, give me the actual command for Nsight Compute on a command line, and you just copy it and paste it, and then it will profile in Nsight Compute that kernel. It will do like a number of skips, and then there are flags like how many it wants to profile. It will give you all that information. And then two additional flags I just find helpful. -- import source true if you want that source viewer. That's only if NVCC had the flag -line info. So it's a two-step process. And then you can also adjust how much the profiler is going to show you with whatever set you want, -- set detailed or -- set full for that memory analysis section, which showed here, which is just kind of like a view of the device, like all memory flows at least through L2 if you want to go into like device or system, and you'll see like a heat map. If you want that and roofline, you have to use -- set detailed or full, I forget which one. The default is set basic. And then compute sanitizer, it's a correctness checking tool. drop-in replacement for the deprecated CUDA memcheck, but it has all the CUDA memcheck features, out-of-bounds checking and misaligned memory accesses, and then there's 3 extra ones: phrase check, init check, and sync check. Just in the interest of time, I'll let you read about those, and they're all included in the documentation. These are also included in NVHPC or the CUDA toolkits. These are some great resources. I highly recommend these. What the profiler is telling you, the GTC talk is an awesome one. And then YouTube from ALCF in 2021 from our roofline analysis. Yeah, I'll be around in the breakout if you have any questions.